Welcome to this presentation on International Electronic Machines Non-Contact Torque Measurement System. I'm Reich E. Spoor, Research and Development Coordinator for IEM for the past 18 years. In that time, I have overseen multiple projects for the Navy, Army, Air Force, and other military and civilian organizations. IEM is a transportation maintenance, safety, and security-focused company. Founded in 1987 to serve the wheel maintenance measurement needs of the railroad industry, we have since expanded into multiple other areas, including transit systems and commercial vehicles. In addition, we have performed research and development to create wireless sensor systems for NAVAIR and NAVC, NDT, NDE inspection devices for the Air Force, air quality monitoring systems for NIOSH, and many others. We hold over 70 U.S. patents, including some directly relevant to the non-contact torque measurement system. Though this project is for the Navy, it actually goes back all the way to 2002 and an Army project which had the same interest in a non-contact, high-speed, and high-accuracy measurement system that could be used on existing and future rotorcraft. Currently, the transition target is the CH-53K. All current torque measurement systems have one or more shortcomings which make them less than ideal for the application. These may be that they are contact systems, have low liftoff, low accuracy, low speed, or they may require actual changes to the shaft design or manufacture. It is obviously preferable to not have any of these shortcomings, have a non-contact, high accuracy, high speed, and zero modification system with high liftoff. While PMA 261, heavy lift helicopters, is the program of record, this technology can apply to military and civilian helicopters and other forms of transportation as well. IEM's non-contact torque measurement system, the NTMS, addresses all of these shortcomings. Based on a patented electromagnetic sensing method, the NTMS is not only usable for new aircraft, but is retrofittable as it requires no actual modifications to the shaft. We have demonstrated a 3/4 inch liftoff from the shaft, a better than 2% accuracy overall in prototype, and can sample at over 1 kilohertz speeds in order to detect transient as well as steady state torque. COVID caused some significant delays in development over the past year or so, but following the overall success of the alpha prototype, the upgraded beta prototype is now being manufactured. The testbed modifications are complete, and we expect to complete risk reduction testing shortly, which will open the door to off-site and flight testing in 2022. More than sufficient funding remains to complete all tasks of the project. So, what's so cool about the NTMS? Well, first of all, it's a completely non-contact system. That means that during operation, it does not wear, thereby reducing or eliminating the need for maintenance once the system has been installed. Installation itself is simple and requires no modifications to any other component of the aircraft, as the only required components are a set of rings that are applied non-permanently to the shaft and sensor coils that are installed at considerable liftoff, up to 0.75 inches from the shaft. The system in its final form will be better than 1% accurate, allowing, along with the high-speed sampling rates, the ability to perform full predictive health maintenance on the system, which is a considerable cost savings compared to standard scheduled maintenance. The better than 1% accuracy also means a far more efficient use of the aircraft's power plant. And this means that you will have an effective increased maneuverability and or cargo carrying capacity. It has the high-speed data collection, which is necessary for PHM and CBM, so that you do not miss transients, and does all of this with very low power operation in a situation which would even potentially allow for generating its own power and thereby requiring no wires at all for installation and use. Flight testing is already planned for the NTMS, and following that, IEM will proceed to certification of the system so that it may be used on board actual operating aircraft. The overall cost total for this work is around $3 to $4 million. We expect, of course, to transition to the CH-53K, but IEM is keenly interested in transitioning to any other aircraft that may have similar torque monitoring requirements. The rough timeline shown is roughly correct, possibly a little delayed due to the COVID delays, but we hope to be able to catch up given the amount of time until final transition. While the NTMS is targeted initially for the CH-53K, the technology itself has a very wide potential market. Not only could it be applied to any rotorcraft, but to any system that has a drive shaft that needs to be monitored for torque. This could be a fixed point generator, another aircraft, even a naval vessel. And this could apply to applications in both military and civilian areas. For military purposes, it fulfills safety, efficiency, and cost reduction needs. This allows it to help in the detection of potential failures, predict the lifespan of the components connected to the drive shaft, as well as the shaft itself. And accurate torque measurement permits the full use of the power plant itself, rather than having to reduce power because you are uncertain as to whether or not you are actually reaching the limits of the aircraft. IAM is very enthusiastic about the potential for the NTMS technology, as it represents a relatively low cost and very high return approach to torque measurement. For our current program of record, which is PMA 261, we still need continuing support for the flight testing, certification, and especially limited deployment demonstrations, which will assist us in moving to full transition. IAM is, of course, very interested in expanding these contacts to other rotorcraft primes to allow us to transition to the other rotorcraft platforms, both in the Navy and the other services. Such prime support would also allow us to eventually transition to civilian rotorcraft, aircraft, and maybe even other applications. Thanks very much for taking the time to listen to this presentation on our non-contact torque measurement system. As shown, I can be contacted through email, my work line, or my cell. Manager of Research and Development, David Metacarpa, will be attending the Sea, Air, and Space Conference. While there, he can be contacted through his cell phone at 518-888-4484. Thanks again.